of this weekly contest 293 of LeetCode, largest combination with bitwise n greater than 0. So basically we are giving a list of integer called candidates, and then our task is to find combinations, the length of the largest combinations. Combination is basically we pick any kind of numbers from the candidates, and then we need to check whether the combination bitwise AND operation, basically we do the AND for all the components of bit combination that we took, must be greater than 0. So that's the condition, and then after that we return the largest length of combinations. So for example here, this is the candidates, right? So the largest combination is actually 4, which is this is one of the combination that satisfies that, where this combination, when we do the bitwise AND operations, it is greater than 0. Okay, this is another example. 8, the largest will be 2, because we can take all 8 and the bitwise operations of it will be 8, which is greater than 0. Okay, so that's a problem, and the constraint is the candidates will always be positive integer with at least one value, and the candidates with at least one, and it could be many. And now one more thing to be explained here, we can now go for the tactic explanations. One thing to be explained here, to be described here to help us to solve this, is to understand bitwise AND. Bitwise AND is basically what it means. For example, if we have number 1 and number 3 and we want to do bitwise AND for this, is first it is considering the binary representations of this, which is for 1 is 001 and for 3 is 011. And the bitwise AND means we're doing AND for each digit of this. So it will be 0 and 0 will be 0, 0 and 1 will be 0, 1 and 1 will be 1. Because anything about AND, if there is 1 0, it will be 0, right? So that is a bitwise AND operations. Okay. Now, how to solve this? A brute force way, of course, we need. What we can do is we try all possible combinations by picking up all the possible combinations of integer here. Like if there is 2 combinations 16 7, 16 71, 3 combinations 16 70 71, and so on and so forth. And that will be a very expensive things because it's combinatorial problem, right? And then it's become factorial things for the time complexity. Now, can we make it faster? The way to do it is to convert the problems. Now, come back to the definition of bitwise. If you notice, the unique things about AND is if anything about it got 0, it becomes 0. And in order to make this greater than 0, it means we need at least, out of our combination, one of the digit have all 1. Okay, have all 1. For example, if we add another candidate here, 010, this will be greater than 0. Why? Because the last digit are all 1. Okay, so in other words, we can convert this problem into the problem of find the largest combinations, the largest number of 1 in the digits. Okay, so what happened here is the largest combinations that has bitwise AND greater than 0 is an equivalent problem with the problem of finding the largest number of 1 out of all the binary digit we have in our candidates. Because what happened here is, if we can have, for example, let's do another one is, what is 2 will be 010. Okay, so it means what it means is we need to scan, and then we can find all the digit that is the largest one. So the rightmost digit will have the value of 1 out of 3. This one 2, this one 1. It means the largest combination will be 3. Why? Because if we took only the one with value of 1 and we eliminate into our combination from the candidates, we will definitely get a bitwise n greater than 0. And that will be the largest, because anything with 0 will be 0. So that's how we convert the problem. Now the problem becomes much more simpler than combinatorial, because what we need to check here is really just counting the number of 1 for each digit. So the tactic will be, first, convert everything into its binary representations. Secondly, find for each digit of the binary, find the largest number n1, and that will be equivalent with the largest combinations that bitwise n is greater than 0. Okay, that will be definitely much more faster, right? Because that means it's just need to do n times the size of the binary. So first is convert to binary representations, and second is find the largest one out of the digits of the binary. So now let us implement the code. Convert to binary representation. First of all, we will need to find the length of the string so that we can fill all of it with 0 when it is less than the largest string length. This is to make us easy to compare it digit per digit later on, so that it's just comfortable during this second part. So in order to do that, what we need is to actually get the largest candidate. Okay, and the largest candidate, actually we need to sort it, and then we take the last of it, that will be the largest. Doing this, we know that the largest the binary length we need is the length of the binary conversions of the largest candidate, which we can do in Python like this. Now we get the binary length, we can do the binary representations of the candidates. Okay, it's basically, we will look for its candidates and we will do a conversion, which we can do with something like C, B, and then we fill the leading 0. We fill it 0 fill, what is it called? Binary line. Okay, so this is how we convert everything into binary. Now we will find the largest one out of the digits. What we do, it means that for each digit, so for I in range of 0 to the length of to the binary length, so for each digit we will go through its candidate and count for the value 1. For C in candidates, for C in candidates, if Ci is 1, then we will increase the counter. Then the largest, at the end of doing the counter, we will calculate the largest. And after that, at the end, we just need to return the largest. Okay? So that's about the code implementation. Let's try it. There is an error. Integer tile is not subscriptable C. Oh, yeah, right. Because I need to use the binary representation to loop this, not the integer one. This one was 4, expected answer was 4, so it seems to be correct. Let's do all the example test case. 4242 seems correct. Let's submit this. It's accepted. It means it's fast enough to be accepted. Now let's go for the time complexity. Okay, sorting means big O and log n. Largest candidate and so on, then bin candidates. This will be C in candidates is big O n. This one for I in range of 0 and binary length, this will be big O. Well, the length of the candidate, is there any constraint? There is not. So it will be, what you call it? Let's call it M, which is the what you call it? The size of the candidate. Okay, the size of the candidate. That will be, of course, that will be a log 2 of the 10 to power of 7 at maximum. Let's just call it M, which is the size of the binary, and then this, for each of it we need to go to the candidate, and n is the length of the candidate. This is big O n, and then this is just comparison, addition, comparison. So basically, because this is inside of this, we need to bubble it up as a multiplication. So this become big O m times n. And then after that, we just return it. Now we have all this sequentially. It means that this is a summation. Big O n log n plus big O n plus big O m times n. The largest will be big O m times n. So this is about this. This is the time complexity. And that will be it. Thank you for listening in.